This lesson is going to show you how to complete the second thread as a part of the table lamp project. And we're going to be taking a look at the Unified National Course thread. Otherwise, the abbreviation is U.N.C. And we're going to be taking a look at this picture right here. Right? So this bottom part of the image shows the external thread, and we have the internal thread above. So our pitch, very similar to the Acme thread, is traveling from the center line of the thread form. It's going to be our pitch divided by 2. This time our angle used will be 60 degrees. And again, we're only going to be drawing one thread profile, basically the shape of a cutting tool that will go through and cut the thread along the diameter of the shaft all in one shot. So we know we have to divide our pitch by 2. We also know our angle is 60 degrees. So we need to find out what our pitch is. So if we go back, and I've been clicking through on the hub. So this is the Wikipedia form right here, page that I was just looking at. And I'm going to be taking a look at Theoretical Machinist next. And we're going to find out what our pitch for this thread should be. So I'm going to go into the thread builder, find definition. I'm going to scroll down to 1 1/8, 7 U.N.C, and that's going to give us 7 threads per inch. Unified National Course class is 2A. This means external thread. Compute. That's going to give us here, we can take a look, and our pitch is going to be 0.1429 for this. That is our full pitch. So we need to remember that number. Next, we can go back and we can click on this link here, Eagle Fastener. This might take a moment to load up. Okay. So National Course threads, sizes, Unified National Course measured in inches. So we can scroll down here and find 1 1/8. There's our decimal form, 1.125. 7 threads per inch. And 1.032 is our basic pitch diameter. That's to the center height of the thread form. And 0.941 is the minor diameter of the thread. All right, so I'm going to use the 0.941 as our minor diameter. So that's everything that we should need to know to be able to draw the thread. So we're going to go click into the lamp, and I'm going to restore the visibility of the work plane by right-clicking work plane and turning on visibility. Okay, so we're going to create a new sketch on this work plane, and we're going to snap to this endpoint, come down, and draw this profile. Okay, so that looks good. We're going to draw another line, a construction line, here in the middle, from one side to the other. And we're also going to make this equal, because this needs to be symmetrical, and like the Acme thread, I'd only sketched it roughly. So now we can set our angle. We know our angle for this has to be 60 degrees. And we know that our pitch from here, this is going to be our pitch divided by 2, as per the Wikipedia page. So our pitch is 0.1429 divided by 2, which will give us 0.071. Let's see, is our pitch listed here? No, it's not. Just going to double check this. One and 1/8. Okay. 0.1429. Yes. All right. And this, we also have to put our center line in. So I'm going to finish sketch for now, and I'm going to edit sketch again, and I'm going to slice this graphic here so I can put that center line in to be able to create. So I'm going to go up, grab line, go up and grab center line, snap from here to here, and we're going to create a dimension from here to the center line, and this is going to be 0.941. Okay, so let's go back for a moment and let's double check. .941. Okay, so this should give us 1.032. And this will be a driven dimension. So I'll click from here to the center line, and it gives us 1.033. That's pretty darn good. That's only 1/1000th of an inch off. So I'm going to call this complete and correct. So at this point here, we're going to hit Finish Sketch, and we're going to create the coil. So again, coil, our profile is selected. We have to select the axis, which is this center line here, and that's going to create the coil, but it's going the wrong way, right? So what we want to do is reverse it this way. So hit the axis button here. That's going to send it the way we want it to go, and we're going to go to this is going to be a cut. So we'll do that while we're here. And we're going to go to coil size. Pitch and revolution needs to be changed to pitch and height. And the pitch is the full pitch, 0.1429. And like we looked at before in the Acme thread, that's not going to reach, so we're going to have to go longer. So we're going to go with 1.5. So it'll start here, come down, cut into the diameter, and come out and exit here and start cutting air. At this point, we can probably hit OK, but what I want to do is I want to be able to change the rotation of this, because I want this to be a left-hand thread. So what we'll do is we'll hit rotation, and we'll hit OK. All right, so there it is. Now let's check something here. Edit feature, and we're going to, yes, so this is how it should be. Okay. We want it to be going the opposite way of this one. All right, so this is correct, the way we see it here. So just make sure you flip that orientation, and we're having it going the opposite way as the Acme thread. And that concludes your lesson on how to create all the threaded coil features in the lamp project. And we'll just quickly take a look at the machine shop drawing sketches again. And here it is, right here, 1 1/8, 7 national course thread. Of course, I'm designating it as a left-hand thread for our plans. One thing that we're not going to be doing is the key seat. So we're going to be leaving this out. And one thing we are going to be doing is adding the pipe thread. So this is a 1/8, 27 national pipe thread, 1/2 inch deep. Now this is here to allow the socket to be fastened to the spindle. So that's something I'm going to show you a bit later. And so anyway, that is your lesson for today. So that's what I want you to work on, and I will talk to you later. Take care.